Section 6.2 is on page 313, talks about systems of linear equations and determinants. We already discussed determinants in section 4.7. We did the determinant for a 2 by 2, and we did the determinant for a 3 by 3. We called it the cross product, if you remember. We used it for cross product, I mean. So given a system of equations, this is Cramer's rule to solve systems of equations. Given a system of equation, ax plus by, the determinant of the matrix is simply the determinant of the coefficients. So that's A, B, C, and D, and we know what that is, the product of those minus the product of those. That's from 14.47. Now, something new that the author, Cramer, talks about. If you determine what d sub x is the determinant, what he does, if this is x, he would replace the x by the constants, and that would be st, and then the y value remains the same, so this is by definition sd minus bt. And also he sets up d sub y to be, well, can you guess? If this is y, then he's going to replace the y by those constants, and those are going to be the s and the t, and the x's will be the same, and that's going to be at minus cs. And then Cramer says, well, if d doesn't equal 0, then you find the x value, that's the determinant of x divided by d, and to find the y value, that's the determinant of y divided by d. So he used determinants to solve systems of equations. We're going to try a couple of problems and see how that works. Well, for this problem, the determinant of the matrix is actually, again, the coefficients, 1, 1, 2, negative 1. So the directions here, solve each system of equations using Cramer's rule if applicable. Oh, there's a part we left out. Let's get that out of the way. That's the part that was missing. If Cramer's rule is not applicable, say so. Cramer's rule would not be applicable if the determinant equals 0 because you're dividing by that. So, this determinant is the key. If it doesn't equal 0, I can't use Cramer's. That will be a negative 1 minus 2, which is a negative 3. So, all good. If I want to find d sub x, the way it works, I would take the x, and instead of the 1, 1 that I used right there, I'm going to use the 5, 3. And the y remains the same, 2, negative 1, and that would be a negative 5 minus 6, which is negative 11. And if I find d sub y, I'm going to do the same, except now I'm going to really replace, I'm going to replace the y column by the constants. That's going to be the 5, 3, and the x remains 1, 1, and that's going to be a 3 minus 5, which is a negative 2, and x is d sub x divided by d. Well, d sub x is a negative 11 divided by negative 3, so it's 11 over 3, and y is d sub y divided by d. That would be negative 2 over negative 3, which is 2/3. And we would know that the solution to this system of equations is 11/3 and 2/3. And for a 2 by 2, that's pretty much it. And for a 3 by 3, notice the x's, the y's, the z's, and the constant. First, I find the determinant, which is the x, the y, and the z. And if that doesn't equal 0, then x will equal d sub x divided by this d. d sub y equal d sub y divided by d, and z d sub c, the same as what we did before, except when you go for d sub x, you would notice that they replaced the x. When you go for d sub y, you notice that they replaced the y's by the constant, and d sub z, they replaced the z by the constant, and the same deal, except now we want to find the determinant of a 3 by 3. We already did that back in the days, if you remember, that's last week. And we did that with using just the first row. I'm going to show you a couple of tricks really quick, and that works on any 3 by 3. So we did this when we did the cross product. If you remember, we talked about determinant of a matrix, and we said you always take the 1, and you cross if it's path and it's column, and you're left with 3 minus a negative, which is plus 10. And then, remember we said you always take negative 3, and you will have 18 minus a negative, so plus 40, and you get to the last, which is the negative 2, and you cross its row and column and multiply by a 12 minus 8, and that's how we did every problem. And this turns out to be 30. This is 58. 58 times 3, that is, what is that? Negative 24, 15, negative 174. And this is a 4 minus 8, and that turns out to be 30 minus 182. Negative, a mistake was here, this was 13, my mistake. And what is that? Negative 12, 181, 7, negative 169. And there it is. So that's one way of doing that. You could do that on every problem if you wish, of course, but I want to show you how this works. It turns out associated with every matrix is a list of signs called cofactors. You start with a positive and you alternate on the signs, in which in a row or column you can never get two positives in a row or two negatives in a row, and this diagonal, this is called the diagonal. The diagonal will always be a list of positives. So for a 2 by 2 it looks like that. If there were a 4 by 4, now remember, you can't start with a positive because that will match, so you really have to start with a negative. If you look at the diagonal, it should always be positives, and you shouldn't have any two signs identical in a row or column. If I come back to this problem, now we've been picking this in 14.7 all along, and the reason we multiply this by a negative because of this minus. Let's say I don't want to pick that row. Let's say I decided to pick row 2. Row 2 associated with this. Well, watch how this works. So this is a negative. I'm going to get a negative times a positive 6 times, and now if I cross 6's row and column, I'm left with a 9 minus, which is plus 4. Then I'll get a positive times 1, that's positive 1, and if I cross that row and that column, I'll get a 3 plus 16 minus times a negative is a positive 5, and if I cross that negative 5 row and column, I'm left with a 2 minus 24. So any row or column, as long as I maintain this cofactor table, I'm in good shape. It'll work. And now if I evaluate those, that is negative 6, that's a 13, plus that's a 19, and that's 5 times negative 22. So this is 10. negative 19, and a minus, what is that, 60, 78, so that is negative 178 plus 19, oh, something's wrong. That was 110, not 100, so that makes this 188, not 178, and that turns out to be negative 169, and it doesn't matter how you do this. No matter how this works, you're going to get the same value. There is another way, a shortcut. That is, there is, if I take number 12, if I list the first two columns, this only works on a 3 by 3, only 3 by 3. If I take the product of those, that's 3, the product of those minus, what is that, 24 times 24 times 120 minus 24, subtracting off the other direction, negative 16 minus 10, 9 plus 54. I know those are hard to see, I'm sorry about that, but this would be 3 minus 144. This is negative 26 plus 54, so distribute the negative m, plus 26 minus 54, that is 29 minus 198, and can you guess what that equals? That shortcut only works on a 3 by 3. If I look at number 35, well, I start off with finding d. 1, 2, negative 2, 2, negative 4, 2, negative 1, 1, negative 3. d sub x is 1, 2, negative 2. Oops. We replace the x values by the constants. So that would be negative 3, negative 7, 4. The y's are untouched, and the z's are untouched. d sub y, we replace the y values by the constants as you see. And since this is a 3 by 3, you could use the shortcut if you want. Make sure you have it memorized. And d sub z would be the x untouched, and in place of, we would have a negative 3, negative 7, and a 4, and we know that x is d sub x over d, y, oops, oh man, trying to finish under 3 minutes, y equal d sub y over d, and z will equal d sub z over d. And remember, keep in mind, actually not remember, on a test, I ask you to find, use Kramer's rule, no, not if, when I ask you on the test, I'm going to ask you for one of them only. You don't have to do all three. So if I decided to find d sub x, I could use the shortcut. That is, I could say, well, let me add the first two rows, two columns. That's fine. And I could say that is 12 times 4, 36 negative, plus 8 minus 14 minus a 16 plus 6, and that is a 6 plus 42, whatever that is. Or I could, if I want, say, you know what, forget that. I am going to take d sub x, which is negative 3, 2, negative 1, negative 7, negative 4, 1, 4, negative 2, negative 3. Pick one of those, rows or column, and proceed. So if I picked, say, this, associated with that, I could say that is a 4 times 2, negative 1, negative 4, 1, minus a -2 times -3, -7, -1, 1, and the list goes on. So your choice, and there's the homework. Only 3 by 3. So